A kill switch, also known as an emergency stop or e-stop, is a safety mechanism used to shut off a device in an emergency situation in which it cannot be shut down in the usual manner. Unlike a normal shutdown switch procedure, which shuts down all systems in an orderly fashion and turns the machine off without damaging it, a kill switch is designed and configured to A, completely and as quickly as possible abort the operation, even if this damages equipment, and B, be operable in a manner that is quick, simple, and, usually, C, be obvious even to an untrained operator or a bystander. Many kill switches feature a removable barrier or other protection against accidental activation. Kill switches are featured especially often as part of mechanisms whose normal operation or foreseeable misuse may cause injury or death. Designers who include such switches consider damage to or destruction of the mechanism to be an acceptable cost of preventing that injury or death. Applications: a similar system, usually called a dead man's switch, as its name suggests, is a device intended to stop a machine in case the human operator becomes incapacitated, and is a form of fail-safe. They are commonly used in locomotives, tower cranes, freight elevators, lawnmowers, tractors, jet skis, outboard motors, snowblowers and snowmobiles. The switch in these cases is held by user, and turns off the machine if they let go. Vehicles. On railways, an emergency stop is a full application of the brakes in order to bring a train to a stop as quickly as possible, much like an emergency brake on a train. This occurs either by a manual emergency stop activation, such as a button being pushed on the train to start the emergency stop, or on some trains automatically, when the train has passed a red signal or the driver has failed to respond to warnings to check that he/she is still alert, which is known as a dead man's switch. In large ships, an emergency stop button pulls the counter shaft for the fuel pumps to the stop position, cutting off the fuel supply and stopping the engines. With a controllable pitch propeller, the stop button may declutch the engine from the propeller. NASCAR requires all their stock cars to be equipped with a steering wheel-mounted kill switch, in case the accelerator pedal sticks and the driver needs to shut down the engine. Kill switches are also used on land vehicles as an anti-theft system and as an emergency power-off. Such devices are often placed in bait cars and configured so that observing police can trigger the switch remotely. A related concept is the dead man's switch, where the operator must be holding a button or lever any time the vehicle is operating. A common example of this would be the kill switches used by boaters wherein a cord connects the kill switch to the operator, and if the operator is thrown overboard in an accident, the cord will pull the switch and immediately shut down the vessel's engine. This prevents it from becoming a runaway vessel that could impose a danger to other vessels or swimmers at sea, and allows the operator to swim back to the vessel and reboard it. Machinery. On large industrial machines, an emergency stop button is typically located on the panel, and possibly in several other areas of the machine. This provides a rapid means to disconnect the energy source of the device to protect workers. For fail-safe operation, the emergency stoppers button is a normally closed switch which ensures that a broken wire will neither accidentally activate the emergency stop nor prevent it from being activated. On machinery controlled by a programmable logic controller, the emergency stop is designed in a way that it overrides the output of the controller. In some contexts, such as nuclear reactors or data centers, the emergency stop is known as a scram switch. In the European Union, most types of machinery are required to be equipped with an emergency stop according to the Directive 2006/EC. Exceptions apply for machinery in which an emergency stop would not lessen the risk, as well as for portable handheld hand-guided machinery. A kill switch is also used for gasoline pumps or any other device that pumps large amounts of explosive or flammable chemicals. Most vehicles nowadays also have a kill switch that cuts power to the fuel pump if the vehicle is overturned. There is commonly a single kill switch for all pumps at a pumping station. The kill switch is also used on such things as industrial band saws and belt sanders. Kill switches are also found on school-use electric power tools such as drills and wood metal lathes. Elevators and escalators. Elevators often have a red two-way button on the control panel which is either marked emergency stop or run stop. Normally, The button is in the up, or on push position, allowing the elevator to run in normal service. When the button is pushed, the elevator comes to an immediate stop. When the button is pulled back out, it resumes normal service, thus the reason for the use of the phrase run stop. In some cases the switch is similar to a light switch, with the switch being in the up position for the elevator to run in regular service, and thrown down to stop the elevator. Escalators will typically have a key-operated control that will turn the escalator off, or change its direction to up or down. Next to the key switch will be a red emergency stop button, which is used in the event of equipment failure, or where there is a potential for injury, such as when someone's shoe gets stuck in the comb at the top or bottom of the escalator. The key switch is used to return the escalator to service after it has been stopped. Musical instruments. An electric musical instrument, such as a guitar or bass guitar, may have a kill switch, also known as a stutter switch. It is used infrequently but most commonly in heavy metal music. A kill switch works by switching between the hot signal from a pickup and the ground signal, and does not break the circuit. A typical way of achieving this is by turning down the volume on one of the pickups, then alternating the pickup selector switch between that pickup and one with the volume turned up. They are sometimes used when a singer doubles as a guitar player and isn't playing, or sometimes used as an effect during a song. Kill switches are rarely a feature in production model instruments, although they are mainly an aftermarket modification and a feature on custom shop instruments. The kill switch circuit can also be built into an effects pedal and controlled by a foot switch. Well-known users of the kill switch circuit are Tom Morello of Rage Against the Machine and Audioslave, Victor Smolsky of Rage, Josh Elmore of Cattle Decapitation, Buckethead, Ace Frehley of Kiss, and Johnny Greenwood of Radiohead. Jack White uses a kill switch during some of his performances and in songs like Icky Thump. Greg Ginn of Black Flag achieved the notorious feedback scream which opens most of the tracks on Damaged with a kill switch. More recently, Eddie Van Halen has been using a custom EVH Wolfgang guitar on which he has had a kill switch installed. Gym treadmills often use a safety key that the runner clips to his or her waist, so that the safety key is pulled out if the runner falls, and the machine stops immediately. In other cases, treadmills have a more traditional kill switch, often mounted towards the rear of one of the hand railings. Amusement rides. The emergency stop on an amusement ride is similar to that on industrial equipment. Typically, brakes on a ride are designed to be disengaged when power is applied. Disconnecting power will cause all brakes to engage. Most amusement rides have a computer that can, similar to the rail example provided above, engage the emergency stop when such a ride is determined to be out of operating specification. Computer software. The concept of kill switch may also be applied to software as an anti-piracy feature, most notably in Windows Vista. It renders the software essentially useless to users running what is determined by the software author to be an illegitimately obtained, or pirated, copy. In the example of Microsoft Windows, the company developed a verification tool named Windows Genuine Advantage, that originally activated a kill switch, or reduced functionality mode, on what Microsoft's mandatory software deemed to be an unlicensed copy of the operating system. Software kill switches have been shown to have varying degrees of success, as false positives have been known to occur, prompting some vendors like Microsoft to turn off the software kill switch in response to market pressure. There is some anecdotal evidence that some software vendors install kill switches in their software to enforce planned obsolescence, also known as a forced update. This can cause considerable disruption in said customers' business functions. With the shift towards application stores for software distribution, particularly on mobile devices, Apple, Google, and Microsoft maintain software kill switches which allow software to be remotely removed from devices, most prominently to guard users against security threats. Smartphones. There have been increasing calls for remotely operated kill switches to be enabled on smartphones. See also, RF shielded cabinet, hardware Trojan, Internet kill switch, blue light station. References